In this presentation, we're going to be looking at some of the enhancements that have been made to Bullet, AMD's open source physics engine inside of Maya 2015. We're going to be using Bullet to do a rigid body simulation of this spaceship crashing into this column and having it fall. So right now what we're looking at is the actual rendered piece of geometry that ultimately we want to have our physical simulation applied to. So this is geometry that's been broken into a variety of different chunks. To work on the simulation, we're actually going to be building it up using some proxy geometry and then transferring the simulation from that proxy geometry onto this high-res geometry using the new Alembic workflow inside of Bullet. So let's go ahead and switch this over to the layer that's got the low-res piece of geometry and begin setting up our sim. So what we have here is we've got this tower. It's got the same exact chunks laid out inside of it. They're just lower-res geometry. And we want to solve this using the Bullet physics engine. To efficiently work with large data sets, we have something called rigid sets that are new in 2015. What rigid sets allow us to do is they allow us to take a variety of objects and solve them as though they're one rigid body. So we can grab hundreds and hundreds of objects. In this example, we're going to grab 2 folders full of the chunks that make up the top and the middle part of the tower, and we're going to create a single rigid object from those through the use of a rigid set. So we'll say Bullet, create a new rigid set. And what this does is this not only gives Bullet an efficient way of processing large numbers of objects, but it gives the artist an easy way of interacting with it because you have one node that allows you to adjust all the attributes for all of the objects inside of that rigid set. So we can go ahead and hide that now that we've made that rigid set. The next thing that we need to do is we need to add in some geometry for this object to collide with. So we'll grab the bottom part of the tower and we're going to create another Bullet object. This time it's going to be a passive rigid body, a collision object basically. We'll switch that over to become a hull type, and we'll make sure that this is set to static. We'll apply that. And the last thing we need to do is grab this ground proxy piece of geometry. And this is just a piece of geometry I made using the quad draw tool that goes across a variety of different pieces of geometry, and it builds up a simplified mesh across the ground plane and up this tower that we're going to use as our last collision object. So for this one, we'll switch the type over to mesh. We'll apply this window and close it. So now if we zoom in here and we play this simulation back, it's going to look kind of funny. This is what I expect. What happens is it just explodes, right? And the reason it explodes is because the collision type is incorrectly set. The collision type for this rigid set was set to box, so therefore there was a lot of self-penetration happening, and that's what's making it explode. So all we have to do is go to the attributes for that collision object, that rigid set, and switch its collision type from box over to hull. So now that we've done that, let's go ahead and rewind this one more time. Let's jump over to our solver node. I'm going to change a few of the attributes on this. I want to make sure that my gravity is -98 to adjust for the size of my scale of my scene. It's also worth mentioning that Maya fields can be added onto your rigid objects now inside of 2015. So this opens up a lot of different options for you. It gives you a very strong set of tools in the sense of the classic Maya field to interact with your rigid body simulations inside of Maya. So now if we play this back one more time, what's going to happen is it's going to do exactly what you'd expect. It's going to fall to the ground and collide with that ground plane. So you can see how quickly that happens. So let's go ahead and rewind that guy. Now really what we want to have happen is I don't want that just to drop to the ground right away. We want that to drop to the ground when something collides with it. So if we go to the initial state for that rigid set and tell it that it's sleeping, rewind that, hit play one more time, you can see as that playback head starts to update, basically nothing's happening, right? And that's because nothing's interacting with that. Nothing's woken that up yet. So let's go ahead and add in some more objects into our simulation. Let's grab our ship, and we'll turn this ship into an active rigid body. It's just box is totally fine for this example. So now if we play it back, obviously the ship's going to start to drop also. Pretty straightforward. So we're going to grab that ship. We're going to go to its rigid body, and we're going to tell it to have an initial velocity of, I don't know, -400, something pretty fast. Play this back. So ship comes in, hits the tower, knocks it, it falls to the ground. Pretty straightforward. So what we're going to do is we're going to increase the mass of that ship to something like 7. We'll replay that back. Obviously it hits it with a good bit of force now. And notice that everything is kind of falling apart. These objects objects aren't really sticking together. Like this top part of this tower is not sticking together at all. So what we want to do is we want to use another option that comes with rigid sets to join these objects together. All those individual chunks, I want to have them have relationships to each other. And we do that using glue. So let's go ahead and jump over to our rigid set. We'll grab that node one more time. We'll turn on glue shape. Now if we turn the glue shape on and we just jump back to the solver, we have the ability to display lots of different information with the solver. Let's go ahead and jump over to a wireframe mode here. So if we turn on constraints, we just turn that glue on and we rewind this, kind of mark that guy, you can see all these little dots. Those little dots are basically showing me where these objects are going to try to get glued together based on that strength. So strength is sort of like a threshold. So you can have more or less constraints by adjusting the number. We'll leave it at the default value of 6. And there's some other things that are pretty interesting inside of here. There's things like, we'll just leave this on here, like we'll turn off the constraints for that, but we'll turn on contact points. So if we start playing this back, you'll see as soon as we play this back, as soon as the objects become active and they have points that are actually within collision, those contact points turn on. So you can see as these objects come down, all the points that are actually having contact are giving me these little dots. And that really lets you see how the energy is traveling through your sim. Some other ones that are pretty cool are the center of mass one. So if you turn the center of mass one on, you'll see these guys are starting to basically change color. And that's showing me which objects have gone to sleep. Bullet's a really efficient engine. If something's not moving, it goes to sleep. So these basically, go through a series of, not sleeping, active, almost sleeping, and then sleeping. And that's what the color coding is showing us. So if we rewind this and play it back, it's sleeping, it's white. It becomes active, they're green. When it gets close, kind of like a light green, it sort of wants to sleep. So as these guys come down and rest onto the ground plane, you'll start to see that they're going to start to kind of click on and become green, light green, and then they'll go to white. So just like that. All right, so let's go ahead and turn off the display of all this stuff. Let's rewind our head, get out of this X-ray mode. Let's jump back over to our node and adjust our glue strength. So if we put this glue strength up to something really high like 100, ship comes in, hits it, and you can see that it really is holding together until it drops to the bottom, and then everything starts to fall apart once that threshold's been exceeded. So the kind of look that you can get changes drastically by just modifying a few of these attributes. Let's rewind that and do this one more time, this time with like a value of like 50. So this one that's going to be a little bit more prone to breaking, it'll fall apart a little bit sooner, probably get caves underneath itself there. So if we're happy with that simulation, what we can do is we can now take this information and send this back out via Alembic and reapply it onto our high-res piece of geometry. So let's just put this to, I don't know, I think 150 is probably enough frames. So we'll go out to 150. We'll go to Bullet. We're going to tell it to export our simulation all to Alembic. We'll just overwrite this one. So the way the Alembic export works is it's going to basically save this information out based on the name. So it's very specific to the name, just transformation information. And we're going to use the ability of Alembic to merge that data back on. So all you have to do is make sure the names are the same and it will just work. It's very, very straightforward and easy to do. So now that we've done that, we can go ahead and jump to our outliner, and we don't need this old Bullet sim anymore. We don't need this guy because we've saved that data out. We can go ahead and turn on our high-res piece of geometry, and we can just get the name to be the same. Pretty straightforward there. Go up to Alembic, pipeline cache import, tell it to merge underneath the current selection, which is my root, and we'll just say apply. We'll grab this data. So now what we've got is we've got our data basically being brought in through Alembic of that sim. So we can finish this off just by turning on something like depth of field, kind of frame this guy up a little bit, and we'll just play this back. So that's just a quick example of a few of the enhancements that have been made to Bullet inside of Maya 2015. We worked with rigid sets and the ability to import and export data using Alembic.